Okay, so I have a confession to make. This lathe, it kind of intimidates me. I got it for free from my friend Craig, and I had the intentions of repairing it. As soon as I started digging into the problems, I got immediately overwhelmed. Instead of addressing those, I just put them off and started working on the little smaller repairs that I thought I could manage. So I started making new lead screws, fixing tailstock wear, and making tooling for this machine. But I was really just beating around the bush around two large problems. So last time I grew a pair and actually decided to tackle one of the problems, that being the spindle bearings. And it turned out to be not that big of a deal, but now I've got a little bit of momentum and I want to start tackling the other big issue, which is the bed wear. And I've done a lot of measurement on this, and I did a video about this, actually making a whole fixture and figuring out exactly how worn my bed was. Then decided, well, I'm just going to pretend like that's not there for a while. I think the best way to actually see what this bed wear means is to actually do some test cutting. See how bad this lathe actually is from a practical standpoint, not just from measurements. Though there will be measurements involved. I'm just looking really hard at that camera. I feel like I'm looking at the eyes of God or something. We're gonna run a full bar between centers and take a test pass across it. I need a way to hold the bar on both ends. We addressed the spindle bearings in my last video, so we know that this end of the lathe is good. But now we have to address the other end of the equation, which is the tailstock, which has a handful of issues with it still. First problem is the tailstock Morse taper. It was really chewed up. So I went through the process of cleaning up that bore, which meant opening the diameter a bit. Now the tools I want to stick in there go too deep. And so my solution to this, after thinking about it for like 3 months, is to just shorten the tailstock quill. My main hesitation about this is that there are etched scale readings on the quill. They're so faint, you basically need like X-ray goggles or something to be able to even read them. So I'm just going to pretend like they're not there, and I'm going to make this an actual usable machine. There we go. Bingo, baby. I have no idea what kind of steel this is, though I suspect it's not hardened, at least judging by how screwed up the inside of this bore was before I corrected that. So I'm just going to start taking cuts, and we'll see how it goes. I think it might be hardened. What on earth? It's literally pushing the... I don't know if you can see that. Hang on. Like literally pushing the cutter away. It's like standing out right here. I took a straight cut across. It seems like it's hardened on the inside, or maybe there's a hardened insert pushed into this somehow. I'm gonna have to use one of my... It's a ceramic... Yeah, ceramic is the word I want. We're gonna try a ceramic insert. This is a cubic boron nitride insert meant for hard turning, which is just a fancy way of saying you're turning hard materials, like hardened steel. It would appear I've already broken the tip off, but it's still cutting, so we're going to continue. Try a finishing pass with the one good edge we got. My first unexpected adventure into hard turning was mostly a success. We got a pretty good finish on that sucker. It's at the right diameter to finally accept... I thought I almost dropped the live center on the ground. The live center I made. This isn't without its own issues. I can't address a lot of them because I can't get it apart. So what I'm going to do is try and tackle them one by one in situ. If I screw something up, well, then I guess I'll just start over. But before we dive into this, let's dive into the sponsor of today's video, Incogni. The name is a play on the word incognito, just without the toe. But Incogni is anything but sneaky when it comes to protecting your personal data. Here's the problem. Whether you're on the internet or not, I guarantee your information is. It's collected, sorted, and sold by these companies called data brokers. And I mean the juicy stuff like your name, address, phone number, social security number, email address, second cousin, even your online activity, including your login information. While most of this is used for fairly innocuous ad targeting, there's nothing stopping it from being sold or even breached to people who are less innocuous. This is where all those annoying spam calls come from that even sometimes interrupt your YouTube videos. But this is just a small nuisance compared to the threat of full-on identity theft, or those absurdly amoral people search sites that put all your information out there for any lunatic to find, for free. This is where Incogni gets heavy-handed, appropriately so. Their software automatically scours the internet and thousands of these sites and requests that your data be removed, which the companies legally have to do. And then Incogni follows up with them, making sure that your data stays gone. You could technically do all this yourself and the companies would have to comply, but who really has the time to do all that? Sure, there's a risk of putting your information in yet another company's hands, but in my opinion, having at least one of those companies in my corner to minimize threats so I don't have to is worth its weight in megabytes. But in the few months that I've had Incogni, the number of spam emails and calls that I get has dropped to a fraction of what it used to be. Which isn't perfect, but it still gives me continuous peace of mind knowing that there's someone working in the background to protect me from the threats that I don't see coming. So get yourself 60% off an annual subscription of Incogni using code INHERITANCE at the link in my description. And thanks again Incogni for supporting this video. Okay, the first problem is that there are no hardened parts on this, and probably the most important is that this tip be hardened. If it's not hardened, it'll just wear out. There's a rubber seal in here that I don't want to melt. So what I'm going to try to do is just very quickly apply some heat to this, get it red hot, and then dip it in the dipping solution. And hopefully we don't melt anything. So, all right, go for it. That went extremely well. As far as hardness, these are hardness testing files. The only one that seems to even remotely bite is the Rockwell 65, which means this is probably in the low 60s Rockwell C. But it also means that it's brittle. Can't exactly temper this tip because I'd have to temper the whole thing in the oven. I think that would cause more damage than good. For the same reason that I cannot temper the tip, I will not be hardening this shank. I can't get it apart. We're just not going to harden this shank. Okay, so that little experiment actually kind of worked. 65 Rockwell file here. Bites a little there, skips, bites just a little bit there, and then the rest of that is hard. I could come back and try and heat treat just the areas that are a little soft, but I don't want to push my luck because this thing actually still spins, which seems like a miracle given what I just did to this, but we're going to keep moving along. The whole point of the live center is that it holds the free end of your part perfectly centered in the lathe, and the only way it can do that is if both this shank and this tip, what's the word? We're going to go with tip, are perfectly in line with the bearings inside. There's no guarantee that that's true. So if I mount this in the lathe, holding on to the tip, this is not the spindle spinning, this is only the bearings. Just a little bit of run out. That's actually not as bad as I was expecting. We need to fix that, which means I need a way to spin this about the bearing axis. And it looks something like this. Basically just a belt tensioning system I made in a previous video driven by this cable sheath that, and that drill spins this. Well, shit. So we have a way to spin this sucker, and to do the grinding, the tool post grinder, use the lathe like normal, except it's a grinder. Because this is a taper and we want to match that taper, it means we need to feed the wheel at an angle. Now there are a handful of ways to do this, but the easiest by far is probably to just use this existing taper as a reference with the indicator. Oh! Fiddlestick! Lathes have pinch points. So now I can run the indicator along this taper. Well, it's kind of dirty. Let me, and just adjust the compound to match. But it's not as simple as that. Do I adjust the angle to the taper here, or where? The best course of action is to find the halfway point between the high and low. So that's kind of the high point, and that's kind of the low point. So we'll find somewhere kind of dead middle, and then use that as the reference. Well, so far so good. There was definitely some run out in the shank in relation to the bearings, and it seems like we're getting a nice even grind off of this. I was worried this wouldn't be stable enough and would sort of deflect away from the wheel, but it seems like we're getting a nice consistent grind. So I've got this colored with a marker. Slide the quill on here, give it a little twist, and pop it off. and it would appear they're rubbing right there. So this wearing on this end but not on the rest of this tells me that this taper doesn't match the one in the quill. I could either adjust the compound angle slightly, or I could just gronk around on this. Test number 2, and we ran out of blue, so red it is. Still not matching, but I think we have another problem. I might need to dismount all of this and machine a little bit off this back face to give me some room. Alright, now to break all this back down and set up everything else again. Alright, take 3, because this is also the third time I filmed this because I forgot to turn the microphone on. Hey. So it's kind of not wearing anywhere, maybe at the front and back. That tells me I'm getting pretty even contact along the entire surface. In other words, means like a glove. So now that that fits, hang on. All that grinding work just got this tapered shank perfectly in line with the bearings inside. Now we need to do the same with the tip. And it looks exactly like it did before. I guess the only real way to see if it was all worth it is to put it in the other lathe. Alright, after all that, we should see 2 things. 0 run out. I don't know how much of that is my hand. The second thing we should see is repeatability when I take this live center out and put it in a different orientation. Bump it out, twist it, put it back. That means this live center is good. So now that we got the live center and the tailstock sorted out and we got the spindle bearing sorted out last time, we're ready to, we are ready to do a bar test. But that doesn't mean I'm going to do a bar test. There's some other things I want to address on this lathe, namely around the tool post. There are like 7 issues with this, and all of them are really annoying. The first is that the tool holders are not the right size. They're one size too large for this tool post. I did a very adult thing and bought some new ones, rather than making them, that is. I've already made tool holders, and it's really not that exciting of a project to do a video on again. So I bought new ones. I also bought a parting blade for this size lathe, which should help me prevent. The second problem is that the compound on this lathe is very puny. Any sort of moment I put on it with the wrench or with the locking cam, it just yoinks the damn angle out of position. There's a few things I'm going to do about this. There are 2 things I'm going to do about this. The first is to make a mod that I did to my other lathe, which is to put a thrust bearing under the lock nut of the tool post. So let's get these bearings in here. Well, just the one bearing. And the other race. Pop that down on there. Run the nut down and give it a gronk. Oh. This whole thing is held down by this cam pin. So I move it, that locks it-ish. And I think the problem is what's underneath. None of this surface is actually touching here, from what I can tell. It's all riding on this bushing. Just take that bushing out and give more surface area to bite down on. If I'm being honest, I don't have high hopes for this. We may have hit on something here. Oh, yeah. Why is that stupid bushing there? Well, that's kind of a problem. So it locks down nice and tight, but now the problem is the pivot, there's a whole bunch of play in it. All that play comes from the play in this. So I wonder if... I said this once before, but it bears repeating. Like a glove. Now we just plop this bad boy right down on there. Anyway, now with a combination of that and my bearing, we can... No, come on, you... Do better. Be better. Why you suck? I guess we just won't tighten that as much. That's what I'm talking about. The headstock's good. The tailstock's good. The live center's good. The compound tool posts and tool holders are all good. So you'd think we're finally ready to do the bar test. Well, yeah. This light keeps humming at me. It's really annoying. Let's see where we're at. 1.472, 1.476, 0.475, 0.473, 472. So there's definitely a taper going on here, and that would certainly... Ooh, that live center is hot. It's pushing the limits of that sucker. Maybe I'll do another pass. Three, 2. So 1.4771 to 1.4732. Pretty much exactly 4th thou deviation across this with a pretty consistent change along the length. So that tells me I don't think I have any problem with the bed wear. It's all just some misalignment in the tailstock. Actually, before I get too far in tearing this apart, I should check something else. So this indicator is mounted on the carriage, and as I sweep it, about 1/2 thou of angle on that thing. Okay, now we can take this off the lathe. So on the underside of this tailstock, there's one very critical piece, and that's this sliver of metal right here. This is what rides against the bedway and keeps everything with this tailstock straight and on the correct position. Otherwise, we get the taper we just measured and taper in the part that we just measured. So I think a good first step is to just take this off and clean up that interface between the two halves and see if that makes a difference. All right, back on the lathe, and that did absolutely diddly. So let's try shimming that little piece of metal on the bottom side. Some 1.5 thousandths shim stock, the thinnest I have, so hopefully that will do the trick. And oh yeah, that actually freaking worked. So we went from running too small to too large on this end, but this is a good thing because I think we can shim this out. Pretty much limited by the increments of my smallest shim stock, but I'm optimistic that this will work out perfectly. .459. Okay, I could keep measuring this to death, but I'm getting the same readings. Yes, I am only about a 2/10 taper along the entire length. Fairly linear for most of this section. This region to this region, it only deviates, you know, 1/2 thou. Well, I guess that's not that bad. So it kind of goes up and down, but it's the worst right here in this region. It changes about 1/2 thou within about 1 inch to 1.5 inches. Pretty steep, but I know where this is coming from. We know that the bed wear is all in this region. Carriage is like dropping down in a well. This is getting wider, and then when it rides back up on the high side, it gets smaller again. And I don't know how much I care about that because we're talking sub-thou tolerances. We might not have to do anything about this bed wear. Yes. Can I impress you with something in the shop? I got something even more impressive than that. I'm gonna need you to do the thing when you get down here too.
All right, I'm here to do the thing. I do the funny and I do the edit. That's what I do.
You do the other thing too?
Not on camera.
So I won't repeat everything that I've done.
Oh, you've learned.
I've learned. You've already edited the video.
Yes.
So you know everything that I've done.
I do.
And what I want to know is what you think of these results. We're going to get this in place so that we can kind of maybe look at.
What are you looking for?
My live center.
Does the tailstock quill being out that far affect the rigidity?
Yes, but I'm taking such light cuts that it didn't matter.
Good question.
Yes, it is. I took a very light skim pass across this. Kind of stays straight through here, but then there's like a pretty significant half thou change in this region, which is where probably most of the work would happen, and probably where most of the work did happen. Do you think this wear is worth tearing the whole machine down, sending this bed off for remachining, or trying to do that myself?
My first question is, I know you've done testing on the bed and you're pretty sure that there's a worn spot there, but
Yes.
how confident are you that those numbers are from the worn spot and not material defects or something?
Composition, I'm 99% sure, because that doesn't really matter. I don't think it's deviation either, because if I was seeing deflection, I'd see most of it out here on this sort of floating end or kind of in the middle.
Okay.
But this bar is so thick compared to the 1 to 2,000 skim cuts I was taking across the length of this that I don't think I was getting material deflection.
How hard is it to disassemble the whole lathe?
The disassembling is not the problem. It's the cost.
Oh, our free lathe is not quite so free.
No. Bro,
Why do you have stuff on the shelf where your stuff is?
I've seen estimates of like $2,000 plus. Is it worth $2,000 to be able to take away a half thou deviation in that first inch? Is that focusing on me?
Yes.
Do I look good?
You look like you.
I see to grill me, not to destroy me.
You're so handsome. Being a deeply practical person who prefers to attempt workarounds, would it be possible to create a custom chuck or spindle extension that would move the area of work holding out of the most worn part of the bed?
Yes. Actually, don't have to do that because I already have chucks. Most of the time, I will probably use this lathe with the collet. And most of the time, I probably don't need a half thou straightness in any given portion. But the times that I do, I could just make sure that I am working on those areas further away from the chuck. Or I just do it on the other lathe.
You're making a real strong case for keeping the paperweight.
That would be a good test, is to just see how straight that lathe cuts the same bar. Even if this was a tenth more precise than that one, it still fits the bill that this is the more precise lathe in the shop. So
Your itty bitty chuck is very cute.
that's itty bitty 4-jaw chuck.
Very small. I would say,
What would you say?
well, I'm not the machinist, and
You're not the machinist.
I often go by what looks good.
You look good.
Oh, okay. I work in tolerances of like a 1/4 inch, so I don't give any flying fiddles about that deviation.
How about, there's a good thing. Let's wait till I get to a project that I actually need that kind of tolerance. In the middle of that very small project, most likely, of turning a shaft that I need to be perfectly straight, we'll send the bed off for remachining. So does that mean this is the end of the video? Or I should ask, what does the audience think? Preferably the machinist people. What would the machinist people do? I may or may not listen to what you say, but maybe you'll tell me it doesn't cost $2,000 to send this thing off.
You have turned the lathe into a somewhat more functional paperweight.
And it was not as bad. Well, we'll see. Who am I looking at?
I don't know. Which one are you married to, me or the camera?
I'm not sure at this point.
And cut.
I'm going to need you to do the thing when you get down here, too.
Do the funny thing or do the shake my ass thing?
Can you do both? Because that would be great.